to determine the best candidate of the test set, we use the greedy technique to searching the best pair. Okay, and the best candidate will be added into final test suite, and uncovered pair list will be updated. This is more in looping algorithm. Okay, and the end of the process, the uncovered pair list will be decreased, and the final test will be increased. Okay. So this is a pseudocode for that algorithm. Okay, and the last algorithm is actual mapping process. As I mentioned the earlier slide, that all the parameters will be translated into the symbolic value. So in that algorithm, we'll read the symbolic value from the lookup table and translate back into the original one. So we can see here, from lookup table, symbolic value after translate in the first algorithm will be all the parameters will be translated into 1, 0, 2, 3, 4, 5. Okay, and before mapping, and after mapping process in that algorithm will be translated back into the original parameters. And you can be assessed 24x7. Okay, the expected outcome is from this paper, weight-based paper tool. Okay, test case generation with minimum size of test cases to analyze and compare the test case result with other test generation tool. Test case view in HTML format and also can be exported into the other format. So this is a simple one, the prototype. Okay. So the conclusion is this framework is support to pair strategy to generate the small size of test case based on input parameters from users. We use the three algorithm which are proposed in order to develop this tool. The actual parameters mapping also integrate the person to execute the parameter mapping for the final test suite. The advantage using the web-based shown in the test case generation process rather than standalone tool, which it has limitations such as lack of UI, less scalability, data sharing, tedious to maintain and deform. To overcome the lack of capability in standalone based tool, the automated web-based test suite generation tool called PESO will be proposed. Okay, that's all. So, question session.
Okay, thank you for your question. So I just want to ask, okay, what is your actual work actually you want to do?
Actual work is more to develop the. Actually, the paper is the purpose of the paper is to develop the web-based pairwise tool using the pairwise techniques.
Okay.
Okay.
How do you want to see that your work is good compared to the others?
Okay. The result from this tool will be compared with others.
You have it.
Strategies. Yeah.
Do you have it done or the?
Not yet. Not yet.
Because
this is a proposal.
Okay, I just want to suggest to you that in order to to introduce something, you need to have something what Kamal said just now. You should be compared with the others. And what are the linking, what are the possible improvement, and so on. I think that's really how you want to do it.
Yeah. So. Yeah, maybe.
Based on your explanation, just to give us me. I don't know, maybe I can learn something from your slide.
Yeah.
So what actually the actual problem that you want to be solved?
Okay. Actually, the main problem, the goal of this paper is more in using the pairwise strategies to develop the web-based to overcome the lack of the standalone the test generation tool.
That is the main issue, right?
Yeah.
So in order to do that, so I think that as a conclusion of your result, you have to go back to why we need to be collaborate, why we need to not just stand alone. This is my reason.
So you mentioned just now you will validate your work against other strategies. Right?
Yeah.
Do you have any other strategies that you tend to compare with?
I think the result from this framework will be compared with the other tool, like just this, like Jenny. Yeah, Jenny. Yeah. We have a 10 or 6 here. Yeah, this year, yes. We using the sample data, 10 parameters and 10 value for each parameters. So the outcome of this paper will be the result from test cases generated by this tool. We will compare with the total number of test cases generated by this tool. So the result will be compared.
Yeah, would you go back to slide 7? So 7. Yeah, there. So I have some questions right there. You're saying sampling strategy such as equivalence partitioning boundary values has been introduced and sample out of test data. That's not true. That statement, it's a very valid selection of input, so I have a problem with that sentence. I would say it's not a sampling strategy. You know, it has limitations, so it's just how you present it, maybe. You need to present it otherwise. And then you say in terms of coverage, no, what coverage? Because there's no such thing called test coverage. There are, on the other hand, millions of code coverage techniques. I assume you mean one of them. And it would be nice to know which one. And of course that needs a reference. That particular statement. Empirical results. Which empirical results? Is it James Bach said so, or is it the Canadian originator?
Actually, they have a reference. I forgot to put here.
Okay, fine. But what coverage is it?
Yeah.
Yeah, what kind of coverage do you talk about?
I need to refer back to the original one.
Oh, okay.
Actually,
Sorry, I supplied the from.
actually, for your question,
Okay.
you have been written too much, but association.
Okay, no suggestion.
Some of the
Statements.
Yeah. Okay, I look through the citations. I'm pretty familiar with many of them, and I know this area. I think now I will challenge you immensely by this statement now. So, shouldn't you? We had heard about reliability today, right? So, how much test do you actually miss by only doing pair ones? So, shouldn't you compare when you do a testing? Maybe equivalence per test actually finds much more faults than only selecting a pairwise. You understand what I'm saying? Because one you select, so this is another selection technique, right?
Okay.
Of input data. We agree that part, right? And now you're also dismissing an immense lot of other information about the test data by using only this information. For me, your example, I would have exhaustively tested that without a blink. And I would say for most web-based systems, you can today in the cloud cheaply, exhaustively test their data if you have a proper dependency analysis. And if you really understand source code here, which I'm a bit worried about, you're not really looking into that area, most of you. You should sort of get the source code statistical analysis part more solid in your mindset. I think you will realize it's not, that much. So I sort of would challenge you on the sense of saying, when you do this comparison, you have to also compare with completely other techniques that you dismiss, and so it becomes a little more difficult than saying, okay, we have selected this and we're expanding the tool. If it's really me, this is what I call the research height, or if you're really going to push the envelope, and that's, of course, what I encourage you to go after, because you believe this has some merit, right? So, how can you show me that that is better than the if-then else checking both of the branches, or you know, a normal coverage support, or you know, you have to.
Okay, I think.
Not an easy one, but this is.
I think we can use the some others tool to check the to test the coverage. Okay. Okay. After the framework is complete, we can use the third-party tools to check the coverage. Okay. And maybe you can compare with others.
Exactly.
Yeah.
But now you also have to do the difficult part, and that's what I'm challenging you. Because, for instance, equivalence partitioning, or it has many names, you know, input partitioning or domains. You know, it depends who you ask and what paper you read. But they have actually shown this is a very common fault developers do. That they switch the larger than equal sign, so the else and the then sign, etc. So by doing equivalence partitioning, you're very likely to find faults that are common. And I mean, I've been working a lot with fault classifications. It's fault that really happens. Now, I haven't seen any statistics. I would love to see it on what kind of faults pairwise testing would really find. I mean, are these two, even if it's really odd combinations, are they likely to ever happen? You know, will there be faults there? So this is where I think you can make a huge difference in research if you go after that. Okay?
Okay. Thank you.
So, good luck.
Assalamualaikum everyone. So, my name is Faisal Sori Muhammadi, and I'm from Faculty of Computer System and Secondary Summit, the previous presenter from University Malaysia Pahang. And my topic for today, rather than a topic, is actually a proposal. Is generating pairwise testing using genetic algorithm. It should be noted that it's still an early stage, and it's, rather than a paper, it's a proposal. So a lot of other improvement can be done. So this is my presentation outline. I start off with introduction, literature review, proposed work, and conclusion. And since it's a proposal, so I don't have any case study, result, discussion, and everything. So straight forward to my introduction. What is actually a software, and why does it matter? We know that I assume that everyone knows that software is the brain of the computer, and the software controls most of human activity. It ranges from a simple clock to a life-threatening device such as an laser. This is just an example on how important it is software. As such, it is important that most of these devices, whether small or big, are to be tested before being put into action. And as much as software evolves from a simple function to a more complex function, so does the effort to test the software increases. To make it clearer, to make it worse, some software are able to interact and work together with other software to achieve the same objective. If we look at the current trend right now, one system can be used to interact with other system. Example as Android. Most Android device can actually, let's say, open Facebook, open any web application and everything. And testing the interaction of the software itself with its own parameter and multiple values that with interaction with other software causes testing to stop. To sum it up, all these are actually related to combination testing. So my scope, my proposed scope, is under specification-based technique under combinatorial testing, and I focus on pairwise. And moving on with literature review, what is actually pairwise? Pairwise is actually, or it's known as by its name pairwise, as all pairs testing. That is testing all possible pair at least once. Here is another example of how pairwise are generated. We have 3 parameters, and each 3 parameters have 3 values. Meaning, if we want to test everything, we will need to multiply 3 parameters with 3 parameters with 3 parameters, then we will have exhaustively 27 test cases. But with pairwise, we can actually reduce it to 9. So how does pairwise work? This is actually interaction between those parameters. In pairwise, we do not care whether it's A, B, or B, A. To us, it's in pairwise. I mean, the scope of pairwise is the same. So we are actually trying to test A, B, or B1 is the same actually. So those two, you can say cylinder is actually referring to the same combination, meaning A1 with B1 and A1 with B1. Okay. Or you can say B1 with A1. So this is more to how actually pairwise cover it. Meaning with one set of combination A1, B1, and C1, you can actually cover those red highlighted area. And some might ask why pairwise. Cohen said that most failure in real software systems are often caused by unwanted two-way interaction between system parameters.